38 kilometers of concrete, open water, no land in sight. It almost wasn't built. You are looking at the world's longest bridge. Over open navigable water built in 1956, engineers had no GPS. No computer model, no blueprint. And one more problem nobody had solved before. What gets me is they didn't just build a bridge. They invented how to build it first. Right here on this lake. Before a single pile was driven, they hit the first crisis. The lake bottom itself refused to cooperate. 30 feet of soft organic mud bearing capacity near zero. The lake could swallow a pile driver whole. Every measurement taken by hand, every reading written in a notebook. No satellites, no sensors, just geometry. The engineers had one design, one lake to cross and 14 months to deliver it. Lake Pontchartrain, 630 kilometers. In a storm. It moves like a small, furious ocean. This is the story of the men who figured it out and built something that still holds. 70 years later. By 1950, New Orleans was growing fast. But reaching the North Shore meant a 90-minute drive around the lake. 40,000 families lived north of the lake. Every commute was a 2-hour round trip nobody could afford to ignore. Engineers knew river bridges, but a river is narrow, anchored, predictable. A lake is none of those things. The first soil borings came back in 1952, the results stopped the project cold for almost a full year. Organic lake sediment compresses under load. It shifts under vibration. Driving a pile into it is like driving into cold porridge. Every boring sample confirmed it. The mud layer wasn't just deep in one spot. It ran for miles in every direction. That mud is decomposed vegetation. Thousands of years of it. Under load, it behaves almost like liquid. It has no backbone. On early test drives, piles didn't sink gradually. Some were simply swallowed, disappearing into the mud in under a minute. They lost equipment on the test program. They lost time. The cost estimate climbed with every boring result that came back. The lake had one final problem nobody had budgeted for. Fog. Total. Disorienting white-out fog that appeared without warning. A barge crew in mid-lake fog had no reference point. No land, no sound, nothing to navigate by except a compass. Navigation was entirely manual. Position was estimated. And an error in positioning mid-lake meant driving a pile in the wrong place. The Louisiana Bridge Commission hired Moski and Masters, one of the most experienced bridge engineering firms in the country. Authorization came in 1953. Budget $30 million. The deadline was implicit. The South Shore construction yard opened in Mattie. Every piece of the bridge would begin its life right here on land. The design team made the call that changed everything. Precast the piles on land. No wet concrete poured in open water. Each pile cast on shore, cured to strength. Then floated out to position on a dedicated supply barge. 16 in square, 54 feet long, pre-stressed, reinforcement inside. And they needed exactly 9,500 of them in the lake. Pile caps were cast separately. Massive concrete collars designed to transfer beam load directly into the top of each pile. Every pile physically inspected before it left land. Supply runs were continuous. Barges moved in convoy. The pile-driving barge was custom-muled, 1M drive. Shallow enough to work across the lake's variable bottom depths. The pile had to enter the mud at the correct angle. 2 degrees of deviation, and the cap wouldn't seat on the beam. The hammer dropped. The pile moved, but not downward the way it should.
4,000-ton aerodynamic steel plate into marine wind streams.
Guide frames were redesigned twice on site. What worked on land testing failed when the barge itself flexed in the lake swell. Each blow measured. Engineers tracked how far the pile moved per drop. Piles that angled in the soft upper mud were sometimes pulled and red-riven. That cost hours per pile, and every hour mattered. The pile's job was to punch through the soft mud and seat in the stiff clay at 50 feet. That clay was the only real foundation. Stiff clay at 50-foot depth. That was the bearing layer. That was what the entire bridge ultimately rests on. Every pile was its own problem. The mud depth varied. The resistance varied. Nothing about this lake was ever consistent or predictable. By early 1955, the pile line was advancing into the lake. They were averaging one full span every 2.5 days. Once piles were driven and capped, the beam crews followed, placing 60-foot span sections across each pile row. Each beam weighed 60 tons. Placement tolerance was 1/2 inch in open water. Grout locked beam to cap permanently. An improperly filled joint meant movement under traffic and movement meant fatigue failure. To cut supply times, a floating precast yard was set up mid-lake. Concrete mixed, formed, and cured on the water itself. They poured concrete on a barge that never stopped moving. Even a small swell changed the poor angle of every form. No shore at lunch. Workers lived on vessels for weeks. Mid-lake was a world with no exit. Total isolation. No road, no hospital, no town. If something went wrong mid-lake, help was hours away. Each completed deck section became the platform for the next. The bridge built itself forward. Heat, glare, and disorientation were constant. Workers rotated off mid-lake every 10 days. Night shifts ran through good weather. Work stopped only when wind made cranes unsafe. 24 kilometers, 14 months. That's 58 m of completed bridge every single day in open water with 1950s equipment. By mid-1955, the southern half was done. The North Shore crew was advancing from Manderville to meet them. The two fronts had to meet exactly. 1 degree of error at the start meant a permanent misalignment. Optical triangulation, angles to fixed shore monuments, pure geometry by hand. It worked. One more feature. A draw span giving 8 m of clearance for sailing vessels on the lake. The bascule hinge had to survive salt air and humidity for decades without failure. It still does. Handrails, expansion joints, road surface, all fitted section by section off the completed pile cap grid. Expansion joints let the bridge flex with temperature swings. They are its pressure relief valves. June 1956, the southbound span opened. 23 minutes to cross. The record was immediate. On opening day, drivers slowed to a crawl. Some stopped. They had never driven over open water before. Guinness confirmed it immediately. World's longest bridge over water. A record Louisiana would hold for decades. The first toll was 93 cents. For many families in 1956, that was close to an hour's wages. The bridge changed the math of daily life. Some drivers had panic attacks mid-bridge.